All right, so I've written some stuff down to save some time. So as you're going through these, you can obviously fast forward to whatever problem you need to make it, so you don't have to watch every second of this video. But I'm going to start out with the first part, so part one, which was the calculator portion. So over here is the question, and over here I got some work written down already. I'll explain it. Some of this I didn't do all the work yet, but we'll get there. So first one, write the polynomial in standard form. So all you have to do is reorder it so that the highest power is first, the next highest power, and then the lowest power is last. So here's in standard form, and then it says, or classify it by degree. It has an x squared, that means it's a quadratic. If it was a cubed, it'd be a cubic. If it was x to the first power, it'd be a linear, and so on. And then it says classify by number of terms with a trinomial, because there's 3 terms, so 1, 2, 3. Number 2 says to find the relative mins and maxes on the calculator. So first off, type it in there. So I got in the first spot here, I got typed in. I'm going to graph that. I'm actually turn these guys off because I don't want to see these when I graph it. Those are future problems. So type it in, hit graph. I may need to, let me change this a second. There we go. So if I'm looking for a maximum, first off, it's that point right there. But if I want to find that exact point, go second, calc. And I'm looking for a maximum. So what I need to do is make sure I'm to the left of that point. So that point's somewhere up in here. Get a little bit to the left of it, hit enter. Ask for a right bound, get a little bit to the right of it, hit enter. For a guess, you can try to get a little bit closer, hit enter. And there's my maximum is, it's 6.06 when x equals negative 1.86. Okay, so that's my letter D for my maximum. Then it says, where's the relative minimum? So do the same thing, go second calc, this time choose minimum. Make sure you're a little bit, so that bottom point is the minimum. I'm going to go a little bit to the left of it, hit enter, go a little bit to the right of it, hit enter, and then for a guess, get somewhere close to it. And it says the relative minimum is negative 0.879 when x is 0.535. And that looks like this guy right here. So that's your A. Okay. Number 3. Number 3 here, it says write it in factored form. Apologize, let me get a drink here. Okay, so first thing I did was always look for the largest thing they're all divisible by, the greatest common monomial factor. So negative 4, they're all divisible by negative 4, and an x. They'll have an x inside of them. So I took out a negative 4x, and this was what was left. And then always check to see if that quadratic can factor further, and it can. What 2 numbers multiply give you negative 30, add to give you 1, it was positive 6 and negative 5. They said factor, so that's all the further you have to go. You don't have to solve it. Okay, so when it says factor, you're done. Whenever it's factored, you don't have to actually solve it. We don't set it equal to 0 in solving. It just says factor completely. Completely means they're all prime. So if you just factor it and you stop here, that's not completely. You got to go completely. Number 4, line these up here a little bit. Number 4, use our calculator for us. Is find the real solutions just using your calculator. So make sure, I'm going to turn this off and this one on. So type into the calculator, make sure it's set equal to 0. So I brought the negative 36 over, now it equals plus 36. Or I'm sorry, plus 36 equals 0. Graph it. And now if I'm looking for real solutions, I want to know where did it cross the x-axis. So I've got 3 spots to find here. If I go second calc, again, I'm looking for zeros now, so choose this. Don't choose min or max, choose 0. And just make sure you're a little bit to the left of this. So if you're trying to scroll, there it showed up. So I'm a little bit to the left, hit enter, a little bit to the right, hit enter, and then, well, that's as close as I can get, so my guess is going to be in there. So one of them is going to be negative 3. So this would be negative 3. Let's find the next one. I'm going to go a little bit faster here. So 0. It looks like it's between, I could scroll it, or it's between between 1 and 3. So I'm just going to put 0. left bound, so I'm going to go 1 and 3. I'm just going to type them in because I noticed between 1 and 3, and then for a guess, it looks like it's about 2. Turns out it is. Yeah, so 2. And then the last one looks like it's between 3, 4, 5, between 5 and 7. So I'm going to go 0, 5, 7. And for a guess, I'm just going to enter. It looks like it is 6. So 6 is the last one. So that's how you find them on the calculator. Number 5, long division. I did the first step here. So I'm looking at these first ones. So x cubed divided by x would be x squared. Now I'm going to multiply. So x squared times 3 is x cubed. X squared times negative 1 is negative x squared. This step is where most people mess up. They'll say 0, 2. But you're subtracting straight down, so I got to subtract both of these. So you're going to switch the signs. Because this was negative, now I'm subtracting a negative, means I'm adding. So this would be a 4x squared. Bring that down. 4x squared divided by x is 4x. Now multiply 4x squared minus 4x. Remember, you're subtracting, so you got to switch those signs. So 3x minus 8. And 3x divided by x would be a 3. That's 3x minus 3. Switch the signs. This would be a negative 5. And it looks like they want you to write it. And here, they want the quotient. So here's my quotient. The remainder is negative 5. Okay, I like it better to put x squared plus 4x plus 3 minus 5 over x minus 1, because that's as a polynomial with a fractional remainder. But this is how MathXL wants the remainder, so that's how you would have got it right. Number 6, determine whether it is a factor, whether x plus 3 is a factor of this. That just means when you do division, you get 0. You can do long division if you want. I elected to do synthetic division. So I'm going to divide by, since this is x plus 3, I'm going to go by negative 3, because that's the root, would be negative 3. So if you remember with synthetic, the first gets dropped down, so 1, and then you multiply. 1 times negative 3 is negative 3. Add straight down, now multiply. Add straight down, multiply. Add straight down. So I got a remainder of negative 4. If you're dividing, you get a remainder, that means it's not a factor. So no, not a factor because I had a remainder. If yours has 0 there, then the answer is yes. Your answer is yes. Number 7, use synthetic division and the given factor to completely factor it. So basically they're saying that x plus 6 is one of the factors. So notice it's already written there. We want to find the other factors. So I'm going to divide by it. I'm going to divide by negative 6 to get that out of there. Whatever is left would be a, if this is a cubic, whenever I divide, I'll be left with a quadratic. I can use quadratic formula to find the rest, or factor if it looks like you can factor it. So drop straight down, multiply. Add straight down, multiply. Add straight down, multiply. And since it was given that it was a factor, they say that it is a factor, you have to get 0 here. If you don't, you messed up. You did something wrong. Now, the quadratic that's left there, those are pretty small numbers. This represents x squared plus x minus 2, which is factorable. Okay, so they've already got the x plus 6 written down for you. You can rewrite it. Okay, well, I ran on memory, so I had to go delete some things. I just caught it. But I filled these in. So what two numbers multiply to give you negative 2, add to give you 1? And it was positive 2 and negative 1. Okay, so that's, luckily I didn't get too far with that before I realized that it was out of memory. So, so there's 7. Let's go to number 8. Line these guys up. Number 8, it says find a polynomial equation with real coefficients that has the given root. So if it has 4 for a root, that means 4 is one of them. If it has negative 10i for a root, that means positive 10i is also a root. And when you want to make it a polynomial, you got to go x minus all those things. So x minus 4, x minus negative 10i, which is plus 10i, and then x minus 10i. If you multiply these two together first, you get this, and stuff cancels out. Notice I got 100 minus 100 of I squared. That makes that a plus, so that's why it's a plus 100 here. These canceled out. So when I multiply these together, I got x squared plus 100. Now multiply them together, and I just put it into standard form to answer the question, because they said, this would be x cubed minus 4 plus 100 minus 400 would be the numbers to fill in there. Number 9. There we go. Get everyone in the same spot. I read it too fast. It just says, if these are roots, what else is a root? Well, I went ahead and multiplied it out. I'm mad at myself for doing that because I wasted a bunch of time. If 17 plus radical 5 is a root, so is 17 minus radical 5. If 6i is a root, so is negative 6i, and that's your answer, those two. So I wasted a bunch of time. Should have read the question carefully. I could pretend like I did that on purpose, but I was just not paying attention. So number 10, it says find all the zeros. Since this is the graphing portion of your test, you are allowed to graph it and get help from the calculator. So I'm going to turn this off. So there's my function, x cubed minus 2x squared plus 25x minus 50. I'm going to graph it and see where does it look like it crosses. It looks like it crosses at 2. So it looks like it's crossing at 2 there. Now, it could be doing like a U or a little bump down here and going up, or it could be going up and then doing its curve going up. But it's a cubic, so it has to be, it's a cubic, so it's got to be doing that N shape. I just don't know where it's happening, but there is at least one root here. So from the calculator, I got 2. So I'm going to do synthetic division using 2. So drop the 1 down to 0. 0 times 2 is 0, 25. 25 times 2 is 50, and I get 0. So it turns out, yes, it is. So 2 is one of the roots. So there's my answer, 2, comma. I don't need to put parentheses. Some of you put parentheses on Math Excel, and I counted it wrong, unfortunately. So don't want to put parentheses. Now what's left is x squared plus 25, which means there is no number that you can square, add to 25, and get 0. So these are going to be imaginary solutions. So since there's just an x squared here, I could try factoring. It's not going to work, but I could do square root. So bring the 25 over, x equals negative 25, square root, that'd be plus minus 5i. So there's your roots for that. Number 11, let's see. Here we go, number 11. Now find all the zeros. Same idea, it's like the same thing, except it's a quartic now. Well, from the graph, whenever I graph it, it looks like it crosses at 2 different spots. So let's go back. Turn this off, turn that one on. Hit graph. Looks like it's going to cross at negative 2 and 2 when it gets there. So there's negative 2, there's positive 2. So those are the first two I'm going to try. And what I did here, again, I did 2. This was my synthetic division, ends in a 0. So that means check, 2 is a solution. I'm going to put these in my answer. I got to include them. So 2 worked. Now I do synthetic division with what's left and negative 2. Well, I got a 0 again, so that one worked. So those two are solutions. What's left was x squared minus 5x plus 7. So put that into the quadratic formula here and simplify. So there's 1, 2, 3, 4. There's my 4 solutions. 2 of them were real, 2 of them were imaginary, but there's my 4 solutions. Okay, so there was part 1. Okay, so this is part 2. So I'm going to keep going here. So part 2, that's right over here. So if people are fast forwarding, they'll see this and know to stop. So part 2. Okay, number 1, determine the end behavior. So all I care about is this right here tells me everything. The one with the highest power. So the leading coefficient is negative. The degree is even. Even means same direction. Negative means they're both down. So down, down would be your answer. Number 2, consider the graph. On this guy here, it crosses at negative 2 and it goes through. So that means x plus 2 with an odd power. Now the only options here is 1 or 2. So I'm just going to say it's 1. It could have been a 3, 5, 7 really, but since this is multiple choice. So this is a 1. And then here at positive 1, it bounces, which means it has a multiplicity of 2, 4, 6, or 8. But again, my only options are 2, 0 or 2, I'm sorry, 1 or 2, so it must be a multiplicity of 2. So that was a squared, because if it has a multiplicity of 2, it bounces. If it has a multiplicity of 1, it goes through. So this is a combination that would make that true. Number 3, find the zeros of the function. Then graph the function. Well, x plus 2 means negative 2, x minus 4 means positive 4, x minus 6 means positive 6. If I were to multiply those together, it'd be an x cubed. So that's odd and positive. Odd means opposite, positive, think positive slope. So this is going up to the right, down to the left. So when I plot my points there, my negative 2, my 4, and my 6, because it's down to the left, I'm going to start from below. So through, and through. There's no bounces because none of these had a power, an even power. They're all odd powers, so they're all throughs. Number 4, find the zeros. The zeros are, since this is x minus 5, it'd be positive 5. X minus 4 is going to be a positive 4. It says, what's the multiplicity of the repeated root? The repeated root is this guy here. 5 is actually a root 3 times. So 5, whoops, has a multiplicity of 3. Got ahead of myself there. Then 5 is the root. So it has a multiplicity of 3. Number 5. 5's over here. Lined up here. So it says find the real or imaginary solutions. Well, first I need to factor it because this is by factoring. This is the difference of 2 cubes. So figure out what's being cubed. So y is what's being cubed, and 4 is what's being cubed. So my a is y, my b is 4. Because it's a minus, that means it goes minus, plus, plus. It's always same, opposite, and then plus on the end here. So if I fill these in, this would be y, 4. A squared would be y squared. AB would be 4y. And then b squared would be 16, because b is 4, so it would be 16. Now it says find the actual zeros. Well, 4 is one of them, so y equals 4. And then plug this into the quadratic formula. Okay, so I want to plug that in the quadratic formula. So negative b plus or minus b squared minus 4 times a times c all over 2a, so it would be 2 times 1. Now under the radical, this would be a negative 48. So first off, right below here, so negative 4 plus or minus, it's going to be an I involved. 48 would be 12 times 4, 4 times 3. Well, I see a pair of 4s there, so I'm going to pull a 4 out front and a 3 is left underneath over 2. And since they're all 3 divisible by 2, now there'd be a negative 2 plus or minus 2i radical 3 over 1, or just leave like that. So there's all 3 of your solutions. 4, negative 2 plus 3i radical 3, and negative 2 minus 2i radical 3. Number 6, find the number of roots. So just number of roots. They don't have to be real, they don't have to be imaginary, they don't have to be anything, just overall, any kind of root. Well, the highest power is 5, that's the degree, so that means there's 5 roots. So that one, don't miss that one. Number 7 says, look at the graph, determine the number of real zeros and the number of imaginary zeros. Well, the real zeros are where it's crossing the x-axis. 1, 2, 3 times it crosses the x-axis. So there's 3 real solutions. It does say the degree is 5. So that means there should be a total of 5 overall solutions. Well, if 3 are real, that means 2 have to be imaginary. Number 8. 8 is the quadratic form. You got x to the 4th, x squared. Well, let x squared equal u and substitute. So instead of x to the 4th, I'd have u squared, and then minus 6u plus 8. Factor that. What two numbers multiply give you 8, add to give you negative 6? Well, it's negative 4, negative 2. Now plug in x squared back in for u. So it'd be x squared minus 4, x squared minus 2. Factor completely. Okay, so this, the difference of 2 squares, that factors more, this doesn't. Okay, so there is it factored completely. There it is. Now set them all equal to 0, so it'd be negative 2, positive 2, and then if I solve this, x squared minus 2 equals 0, bring the 2 over. So I get plus minus radical 2 as the other 2 solutions. So there's 4 total solutions there. Number 9, supposed to multiply them all together. Yeah, I think we got it all on the screen there. So again, minus 7 plus radical 3i, minus 7 minus radical 3i. That's where I got these. And now let's take x times everything, take -7 times everything, and then take radical 3 times everything. I get all this. I distribute everything to everything. Cancels, 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 and then simplify. So add up like terms and make sure it's in standard form. Number 10, use a rational root theorem. So it's all the factors of 1 over all the factors of 12. So I got all the factors of 1 over all the factors of 12. Well, all the factors of 1 is plus minus 1, and this would be 1, 2, 3, 4, 6, and 12. Put 1 over all of them, you get these fractions. So that's your list of possible rational roots. That's B. And then what are the actual roots? Well, start trying these. Out of this one here, do synthetic division until you find one that works. I tried positive 1 first. It didn't work because I got a 10 on the end. So that was not a root. So throw it out. Now try negative 1. It worked. So negative 1 is one of them, which I circled and I put it down here in my list. What's left is a quadratic. Put it in the quadratic formula and find the other two. You don't need to keep trying. You don't need to just keep guessing and checking. Once you get it down to a quadratic, use quadratic formula. So I got 1/2 and 1/6. There's my answers. It just so happened those are in the list, but it would take me a while to do it by guessing and checking. So don't waste your time doing that. And when it gets down to a quadratic, use quadratic formula. And then number 11 just says factor it. So just factor these the difference of two cubes. So I identified first off, what am I cubing? I'm cubing x. I'm cubing 3 to get x cubed and 27. So that's my a and my b. It was a minus, so the first sign matches, the second one's the opposite, the third one's plus. And now fill them in. So a is x, b is 3, a squared would be x squared, ab would be 3x, b squared would be 9. Okay, and this just said factor it. That's all you do. You didn't have to solve. So that's it. We're done with that part. Okay, so hopefully this helps. Again, hopefully you fast forwarded to the part you needed to go to. And if you have any more questions, let me know.